Hi guys, so this is Vicky here. Today we are going to go through the pure definitions of acid and bases that you will encounter at the level of high school and college chemistry. So the first definition is Arrhenius definition, and this is basically what we have been so familiarized with all throughout biology and underclass levels of chemistry. So for this, the definition of an acid is anytime there's a proton being produced. So a proton producer is going to be an Arrhenius acid. So that just means that, for instance, if HCl were to go in water, it will ionize into H plus and Cl minus. In this sense, H plus is being produced. Okay? All right. In regards to base, it's an OH minus producer, so it's a hydroxide producer. So a hydroxide producer is, for instance, NaOH. When it goes in water, it ionizes into sodium and hydroxide. Again, it will ionize and it will produce H plus. OH minus. Okie dokies? Okie dokies. Now, let's continue. Let's talk about the second definition. So the second definition is called Bronsted Lowry. Please don't ask me about the O. I saw it somewhere in a book and it stuck. I don't know where it's from, honestly, but whatever. You can figure it out. If you know, write it down on the comments, okay? And let me know where it comes from. Anyways, Bronsted Lowry acid base definition. This is the definition that we will be using the most often at the level of AP honors chemistry in high school, as well as college chemistry and all of the standardized exams that will grant you an entrance to a professional school. So basically, the definition of an acid is an H plus donor. So a lot of times students look at it and they're like, what the heck, producer versus donor is the same thing, isn't it? It's not, because a donor always needs to have an acceptor. And it's kind of like paired up. If someone donates something, they have to have someone accepting it. Okay, so here the example would be like hydrofluoric acid. So HF would be a Bronsted Lowry acid, whereas F minus would be a Bronsted Lowry base, because this proton from HF will get donated over and get accepted by this F minus. Does that make sense? Okay, so the key to this is that Bronsted Lowry acid and base, the main idea is just a difference of one proton. Always, 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 okay? So if I were to give you some examples, for instance, I have H2CO3. If this one loses a proton, it becomes HCO3 minus. If it loses it again, it becomes CO3 2 minus. Another one would be H2SO4, loses one, it becomes HSO4 minus, and then it loses one more, it becomes SO4 2 minus. And even water, all of these diprotic, multiprotic compounds, and we call them species, right? When they lose protons, sorry, I got a little excited, H3O plus, if it loses a proton, becomes water, and then it loses one more, it becomes OH minus. So if you look at this, all right, so what we're looking at is this. Between these two, which one is the acid and which one is the base? So the one with the extra proton is always going to be the acid. The one with the one less proton is always going to be the base. Okay, let's look at the bottom two. Again, the top would be the acid while the bottom would be its base. Okay, does that make sense? So this holds true for everything. The top would be the acid, the bottom would be the base. Okay, top acid, bottom base, and so on and so forth. Okay, oh look, the one in the center is both acid and base. How does that work? If they're both acid and base, we call these amphoteric species. Okay, you know the word amphibians. It's kind of like amph means both, because amphibians, they live both water and land. Same idea here. It's both acid and base. And it just so happens to be able to do that because it has multiple protons. Okay, so because these are pairs now, Bronsted Lowry acid and base definition basically says, for instance, if I have HF reacting, for instance, with acetic acid, 232. Oh, sorry, that's, yeah, never mind. If I have HF react with ammonia, right? Because what? I would actually want this proton to go here. So let me show you. It becomes F minus plus NH4 plus. Does that make sense? So if you're looking at it, HF versus F minus, this is a pair, okay? And then NH3 and NH4 plus, that's a pair, okay? So now if you look, HF versus F minus, which one's the acid and which one is its base? HF is going to be the acid, while F minus, we call this its conjugate base. Okay, same idea with ammonia and ammonium. Which one has one more proton? Ammonium. So this NH3 is the base, while NH4 plus, it's going to be its conjugate acid. Okay, easy peasy? Easy peasy. All right, last one. Last one is Lewis and acid. Lewis acid base. Okay, so it's Lewis. So Lewis acid and base, its definition, okay, has to do with electrons. Remember Lewis dot structure? It has to do everything with electrons. Same idea. Lewis acid and base has to do with electrons. So this one is going to be an electron acceptor, and the base, it's going to be an electron donor. Now, if you forget which one's the acceptor, which one's the donor, look at it like this. Electrons are negatively charged. Protons are positively charged. We know that every time a proton is donated or produced, it's going to be an acid for Arrhenius and Bronsted Lowry acid and base definition, right? So that's positive, positive, negative. Oh, it got switched. Same idea. Producer, donor, oh, it got switched. It's now the acceptor. Okay? So just look at it like that, and then it'll make your life so much easier. You don't have to memorize, you don't have to strain extra brain power to memorize something extra, okay? So usually the Lewis acid and base, we use this more in organic chemistry when we are trying to create complex ions. So here's an example, BF3 and NH3. Now, boron, it's okay with a sextet, but it would be happier with an octet, okay? Ammonia has a lone pair, right? It just so happens that ammonia's lone pair splits and it goes over to boron like that, and then we create a bond between them, okay? And collectively, this whole thing, okay, is called the complex ion. Complex ion. And this bond right here that we just created, it's called the coordinate covalent bond. Okay, and that's the only time you will ever see Lewis acid and base pairs, unless you go and you do organic chemistry, and in organic chemistry you will learn a bit more and how they actually become bigger compounds with transition metals and whatnot. Okay, anyways, hope this helped, and don't forget to subscribe. I will talk to you guys soon. Thanks, bye.